Okay, so everyone, welcome back to my video. So I'm Mr. Teow. Good morning and welcome. So today we are going to enter a new chapter of additional mathematics in Form 5, which is chapter 2 on differentiation. So I am Mr. Teow. So this is differentiation, in which is on the new chapter of additional mathematics. This one previously is in Form 4, and this new syllabus it will be moved to Form 5. And then for information, this week the video will be a little bit late. The reason is we will skip some of the discussion which it is not included in your exam, but it is come in form of the combined skills that you will use in your examination. So another reason is for this week I will be start doing going on my thesis. So the upcoming video will be a little bit slower than before. Okay, so basically chapter 2 differentiation. This chapter will be focused on and we are going to see what is differentiation is. Okay, so first of all, let us introduce this chapter, which is the chapter differentiation. So in this chapter, we are going to learn three things. The first thing is limit, which is the base of differentiation. After that, we are going to see the rules of differentiation and their application in our daily life. To be easier, differentiation, or we call it pembezaan in Malay, is actually a branch in calculus in which another branch is integration, which we are going to learn in chapter 3. This is the opposite of differentiation. Okay, so calculator teaching. For this chapter, the calculator teaching will be start from application, not for the first two subtopic of the differentiation, but it will be more useful during the application. And it's just used for your check answer only, in which you cannot write directly the answer into your questions during the examination. So apart from the usual calculation, this calculation is usual when you're doing simple arithmetic or the usual arithmetic operations. The calculator can be used to evaluate the value of differentiation only when the variables are replaced with a number. For example, when you place shift plus this button, so you will get the first step, shift plus this button. So this is the circle part that I put here. So when you put a shift plus integrate button in this button, so you will get into the symbol d/dx. So this stands for differentiation with respect to x. So the argument of the function is actually ddx. You have function and you have value of variables in that function. For example, when you have y equal to 2x plus 1 and you would like to find the differentiation of y respect to x at x equal to 2, you will type d dx 2x plus 1 2. So this 2x plus 1, this 2x plus 1 stands for a function, and this 2 is the value of x. That's what you have this one. So the function, and you have value of variables in that function. So in this variable, the function is your variable is x. Okay, and then you need to note for this case, you can only do for single variable. Your calculator cannot do multiple variables. You have only single variables. Okay, so this is what we have. For 2x plus 1 is the function, and you have 2 stands for x equal to 2, or the value of variables in that function. And then after you use the calculator, each time you must clear the mode by press shift plus mode to clear all the mode after use, and all bracket must come with function fraction come with bracket. That's what we discussed before. So solution of limit, this is the first we are going to look into. So limit is the first one that we are going to look. Okay, so first of all, what is limit? So limit actually is denoted with the symbol limit x approach n y. So this symbol is read as limit when x approach a value for function y in terms of x. Okay, so this symbol is read as a limit of y, which y consists of x variables when x approaches n. It's crucial to remember the value of limit for the value doesn't mean it's exactly that number, but it's near to that number. For example, you have a limit of x approach n of y in function of x equal to a, or equal to, we use the common value, u equal to L. So it doesn't mean that y of x, it doesn't necessarily mean y x when n is L, but it means that when x approach n, y will approach L. So you must remember, it doesn't mean y n equal to L. Doesn't necessarily mean this, but it means when x approach n, y will approach L. Okay, so for instance, you have this one. It doesn't mean f1 equal to 2. Doesn't necessarily mean this, but it means when x approach 1, the f value will approach 2. So as the name suggests, the term limit here, it means very near 2. So it doesn't mean you equal or exactly same. So the limit here means hard in BM or 极限 in Mandarin. So there are extra info here. This one you will not run in your educational mathematics. But the extra info here, as approach n, it means you approach from left, approach from right, they will approach the same value. Okay, you will see through this diagram. Okay, you see this diagram. So this diagram, when you can see, this is the limit when x approach 2, your f will approach 5. So you will see when x approach 2, it comes from the right and it comes from the left. So when it comes from the right, come from the left, it approach 2. And you can see this value, the f will approach 5. Okay, so that's why you have a limit fx equal to 5. Okay, now we will see what is the ways to solve your limit. So there are the way to solve limit. The first one, you solve by direct substitution. This is the very basic things that first you need to do during you solve your limit. So when you have direct substitution, you will get three answers. In normal form, you will directly get this answer. This is a very common. You will directly get this answer. Okay, the second part, when you have either indeterminate form, you will get 0 over 0 or infinity over infinity. If you get 0 over 0, you have two ways to solve. First, using factorization. Second part, using conjugate. When to use factorization? When you doesn't see cert. So this is the symbol of cert. When you does not see cert, so you use factorization. If you see cert, you will use conjugate. So this is the difference. Okay, what is conjugate? If you have 1 plus A, so your conjugate will be 1 plus B. So it's similar if you have 1 plus third x. So your conjugate will be 1 minus third x. Okay, this is very important. And then if you see infinity over infinity, so it means you need to do diminishing higher power denominator. It means if your power of numerator is x, is power of 1, denominator power of 2, so you need to diminish the higher power denominator 2. Okay, so there are other forms in which you will get directly the answer as infinity, or you get answer directly as 0. For example, when you have an infinity over a number, let's say infinity over 3. So the infinity over 3, you will still get infinity. A very big number divided by a small number, you get infinity. Vice versa, you have a small number divided with infinity, you get a 0. Why you get a 0? Because it's actually similar around 0. Okay. After all, you must directly substitute again to get the final answer. So after you do all these things, you must use back direct substitution, and you should get back to your normal form. Okay, for example, we will see here. The first example, you have to find the limit when x approaches to 4x plus 1. Okay, so it means that when x approaches 4, you have x plus 1. So the first thing you need to do is you write the question. Okay, so remember our first step is we need to do substitution. So we will do substitution here. Okay, you see here. Can you get the answer? So okay, see, okay, you can get the answer. So you write 4 plus 1 equal to 5. So this is your final answer. Okay, at this stage, when you substitute, no more limit. Remember this one. Okay, so we'll see the second question. What is the mean by this sentence? Okay, find when x approach 4, you need to find this one. So the first step, you will substitute here. So you will see, okay, the first one, you write the question. Okay, and then you try to substitute the 4 here. So you can see when you substitute your 4 here, you substitute your 4 here, you press calculator, you will get, and actually you will get 0 over 0. Okay, you don't need to write this one in the exam, but you need to know this one is 0 over 0. So you see here, there's no cert. So if this one no cert, you use factorization. So how you factorize? You will try to limit the x minus 4. This is actually the cause of the problem. So you will try to eliminate this one. So you will start to do factorization. Okay, first of all, you do two brackets, and then you have x here. So x times x, there's no other things you can do. 16. Okay, when you see this one, actually 16 is actually 4 square. So when 4 square, you put 4, 4. And then you have minus, so this is plus minus over x minus 4. And then what you will do, you will eliminate. Okay, did you substitute yet? No, you haven't substituted, so you need to write the limit. Okay, so you continue write the limit until you substitute. Okay, now you substitute 4 plus 4, you get 8. So this is the answer you want. So directly you write 4 plus 4, which is 8. So at this moment, there's no more limit. Okay, remember there's no more limit here. Okay, for the third question, okay, you want to find the limit when x approaches to 4, 1 minus third x minus 3 over x minus 4. So the first thing is you will write the question. Okay, and then what you will do, you will start to substitute. You substitute 0, what do you get? So it's not 0. You substitute 4. So because it's x approach 4, you substitute a 4 here, you will get 0. This one you substitute 4, you get another 0. So you know this is indeterminate form. You need to do factorization or conjugate. But for this question, you have cert. So what you do when you have cert, you do conjugate. Okay. So remember conjugate. Okay, what you will do for conjugate, you will take the part that you can do conjugate. So the part here is the part with cert. So this part with cert, you want to do it conjugate. So conjugate is this one. Okay, so I will write here your tips to choose conjugate. Okay, tips to do conjugate, you choose those with a cert. Okay, you choose those with a cert. And then those with a cert, you will do 1 plus cert equal to 1 minus cert. So you remember the conjugate is here, not inside the cert. Okay. Okay, after all, you will start to do multiply. So when you do multiply, you will, okay, you haven't substitute 4, so you must continue write 1 times 1, you get 1. 1 times this one, you get positive, minus by this one, you get negative, plus, minus, you get 0. And then you have negative, positive, you have negative, and you have actually x minus 3. Okay, don't forget this bracket over. Okay, and then you will continue. Okay, now you continue to do limit x plus 4 minus plus positive, you get minus, 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 you get positive, and over x minus 4, 1 plus x minus 3, and then you will continue to do until you get final answer is negative 1 over 2, as you can see here. Okay, you can see here. All right. Okay, for example 4, you will find the limit of when x approach infinity, x plus 3 2. So the first step you write the x approach infinity, x plus 3 2. So the same first step you will substitute here. So you try substitute infinite here. So you get infinity, a very big number plus a small number, you get infinity. Over 2, you still get infinity. So you will write here infinity plus 3 over 2. Okay, why no more limit? Because you already in substitute here. So equal to a big number plus a small number, you get a big number. Over 2, you get a big number. So this is a final answer. And then step 5, when limit x approach infinity 2 over x plus 2, this is vice versa. So you substitute x with the infinity, you get infinity plus a small number, you get infinity. Small number over big number, you get a 0. Okay, number 6, you want to find the limit of x upon infinity, x over x plus 2. The first step, you will write here limit x approach infinity, x over x plus 2. So when you try to substitute to infinity here, you get infinity. Over infinity plus 2, you get a infinity. Small number plus a big number. So you will write here infinity over infinity. So infinity over infinity, what can you do? You will do diminishing higher power. Okay, so this is power 1, this is power 1. So what is the higher power? 1 and 1. So the higher power is 1. The same actually. So both power are 1. So it will start to diminish. How to diminish this one? So the first step is you will divide x over x. Then you have x over x plus 2 over x. Okay, and then you will get 1 over 1 plus 2 over x. Okay, and then equal to 1 over 1 plus 2 over infinity. So this is a small number over a big number, you get a 0. So 1 over 1 plus 0, you get a 1. Okay. Okay, now this is for exercise. So this 6 question, first question until fifth question, I think you should understand from the question. And then for number 6, diagram actually shows the function fx equal to x minus 1 over x squared plus 4x minus 5. From this diagram, you need to find this limit, and from find n if the limit is infinity. So you will find the value of n here. Okay, so this one is your homework, and we will discuss this most probably in the next video or in the material link I will attach later. Okay, now we are going to move into differentiation using the first principle. So this first principle is a very famous question being given in the final exam. So the first principle here means you cannot use formula. Okay, for information, after this you will start to learn differentiation using the differentiation formula. But if the question asks you to do first principle, you cannot use formula. But you can use the formula to check your answer. Okay, so you first of all we observe this diagram. You can see this diagram. Okay, from the diagram, when you have x and y at the first moment, so it's actually a graph in which you have x and you have y. Okay, and then when there are small change in x, okay, for example, x change to x plus delta x. Okay, this is actually a small change of x. Okay, when you can see there's a small change of x, y also will have a small change. Okay. Okay, so when there's a small change of x, y will also change. Okay, so this one it means when the small change very approach 0, so it's very near to 0, meaning even is there's when there's a small change of x, then small change of y will exist also. But if your small chance of x approach 0, it means it nearly doesn't exist. Then small chance of y will be near to 0 also. So from this statement, you will see when the small chance of x is approach 0, so it means x plus delta x, y plus delta y will approach the x and y respectively. Okay, so you will see this small change as it change here to here. You see each a point of this point, they have respective tangent or respective gradient. So you can see this gradient is much more changes approach to the original gradient. So it means the ratio of delta y to delta x will also approach the gradient of that function. Okay, so you can see at this part when it is when the small chance of x is approaching 0. So when it's approach 0, so it means that it's much more closer to this. So this y plus delta y also much closer to y, and you can see this gradient is much closer to its original gradient. So this is the basic view of your function or your basic view of your first principle. So the steps involved in the first principle. First question, you need to let x equal to x plus delta x, y equal to y plus delta y. This is to show that your x and y have changed. So from this equation, you will start to find delta y over delta x. And you can see when delta y over delta x, when delta x approach 0, this one will approach this one. So this is the first principle rules. Okay, for example, you want to find dy dx for y equal to 3x squared plus 2x using the first principle. So the step 1, you will let an x change to x plus delta x, y change to y plus delta y. Okay, and then at this step, when x equal to s plus delta x, y equal to the x, y plus delta y, so you have y plus delta y equal to 3x plus delta x squared plus 2x plus delta x. Okay, so until this step, you will start to solve. Okay, what you want to solve, you will solve off the bracket. So you will open up this bracket, you should get 3x squared plus 6x delta x plus 3 delta x squared plus 2x plus 2 delta x plus minus 3x squared minus 2x. Okay, so the step you can see here. Okay, after that, you will start to form. Okay, what is your y here? Your y is actually 3x squared plus 2x plus delta y equal to all this. Okay, I will write here 3x squared plus 6x delta x plus 3 delta x squared plus 2x plus 2 delta x minus 3x squared minus 2. Sorry, no minus 2x here. You have all this, and then you will start to find delta y over delta x. So you have 3x squared, 2x, you have 2x. So what you left, delta y equal to 6x delta x plus 3 delta x squared plus 2 delta x. Okay, and then you move delta x here. So you actually have delta y over delta x equal to 6x delta x over delta x, you get 6x. 3 delta x over delta x, you get 3 delta x. 2 delta x over delta x, you get 2. So you get until this step. Okay, when your delta x approach 0, as well you can see in this graph, you still remember, you have this graph. Okay, when your delta x approach 0, your gradient will approach to its original gradient. Okay, so it means that since dy dx stands for gradient, so it's actually close to delta y or delta x. So when your limit of delta x approach 0, this one will be close to dy dx. So you will plug in this one here and you will get your final answer. Okay, you put here. Okay, so the same concept. After you substitute, there's no more limit. Okay. Okay, so this is the question you are going to solve this one for homework. So all these are using the first principle. So you need to solve this one for your homework and we'll discuss this in the next video or in the material link given. Okay, after all, you will start to enter the third sub um, chapter, which is on simple differentiation. This one we will learn on today. So this formula is not given in examination. You need to remember. Okay, formula you're given in exam only for differentiation. You have only three formula. Sorry, it's two formula. Okay, what is the two formula? Three formula you have? So not two, three. The first formula is product rule. The second formula is quotient rule. Third formula is hand rule. That's all. Only three formula in your exam. So the rest of the thing you need to remember. Okay. So the first one, if your y equal to ax power of n, okay, this means that if your y equal to ax power of n, so your dy dx will be equal to n ax n minus 1. Okay, how you get n ax n minus 1? Okay, you remember when you want to differentiate, your power will be minus 1. And then your n will be moved down. Okay, this one very easy. Okay, and then if you have various multiple, let's say you have y equal to axn plus bx. Let's say like this. So what you will have for dy dx, you will have naxn minus 1 plus b. Okay, why b? Because this is power of 1. So 1 when you move down, you multiply with 1 here. So okay, we will get 1 b 1 minus 1 x. So nax n minus 1 plus b x power of 0. X power of 0 is 1. So we get nax n minus 1 plus b. Okay. So for example, you can also write in f prime x. So f prime x equal to dy dx is the same. Okay, the first example, you want to find dy dx when your y equal to 3x squared plus 2x. Okay, so this one is very easy. 3x squared plus 2x. First one, you need to write y equal to 3x squared plus 2x. And then you have dy dx equal to 2 times 3x, 2 minus 1 plus 2. Okay, 1 you bring down, so 1 times 2 is 2. And then you have 1 minus 1. So you will get 2 times 3, 6x. Okay, and then 2 minus 1 is 1. X and 1 minus 1 is 0. X power of 0 is 1. 2 times 1 is 2. So this is your final answer. Okay, now example 2. You want to find f prime 4 if fx is 3 over x squared plus 3x. Okay, so the first step, you want to find f prime 4. This is the one that you want to find. But before you want to find f prime 4, you must find f prime x. How you want to find f prime x? F prime x is surely dy dx. So you have dy dx. The first step, you will start to see this one. Okay, how you want to transform this one into power? Okay, we will start to transform this one into power. So fx equal to 3x power of negative 2 plus 3x. So fx equal to negative 2 times 3x negative 2 minus 1 plus this one is the power of 1. So 1 times 3x 1 minus 1. equal to negative 2 times 3, we have negative 6, x negative 2 minus 1, negative 3, plus 3x power of 0, and you get negative 6x negative 3 plus 3, or it's actually negative 6 over x power of 3 plus 3. Okay, and then it will start to find f prime 4, which is equal to negative 6 4 cube plus 3, and you press calculator. Remember to put a bracket here, and you get the answer 93 over 32. Okay, a very simple question. Okay, now we have some question. This question will be for your homework. Okay, first you want to find f prime x when your fx equal to 7x squared plus 2 minus 2 over x. So remember, for this question, you need to find f prime x. So this one actually same as dy dx. dy dx for what? For f prime x equal to 7x squared plus 2 over x. So you remember to change this into power. So 2 over x power is 2x negative 1. So you need to transform this one, and then only you start differentiation. Okay, second question, you want to find dy dx for y equal to 10x plus 2 x equal to 3. Okay, so you have a value s equal to 3 here. So for this question, first step you want to find dy dx. Second step you find dy dx when x equal to 3. Okay, so I think that's all for our discussion today, teaching today. So we are going to discuss this question or the answer for this question in the next video or in the material link given. And then in the next video, we will continue to learn more in complicated differentiation and before we get into the application of differentiation. So that's all from me. I am Mr. Teow and see you in the next video. Thank you.